Hello and welcome to Here Tutoring. In this video, we're going to cover the top 10 tips, tricks, and strategies to use to raise your ACT score. So, without further ado, here they are. Tip number 1. Don't take the ACT like it's a normal test. Usually, for a normal test, you have plenty of time to finish, so you start from the beginning and work slowly and carefully to the end. Also, especially for math, you usually have to show all the steps and show the teacher you actually know how to go through the process of answering the questions the right way. But you shouldn't take the ACT this way. First of all, because you won't have plenty of time to work slowly and carefully through all of the questions, especially for the reading and science tests. And second of all, because you don't need to show that you know how to do the questions in the right way. All you need to do is pick the right answer. This is especially relevant for the math test. You not only don't need to show your work for the ACT math test, but you also don't need to do the questions the right way. There are tricks to finding the right answer, even if you have no idea how to do the question the right way. Tip number 2. Bring and know how to use a digital watch. If you're at all serious about getting the highest score possible on the ACT, bringing a digital watch really isn't an option. Bringing a digital watch will help you manage time and pace yourself through each test so you can make the most of every valuable minute that you have. Now, there will probably be a clock in the room that you take the ACT in, but since it probably won't be a digital clock, it'll be harder to keep track of time precisely using this clock. And also, this clock might not be in a convenient location for you to check it regularly and easily. Bringing and using a digital watch yourself helps you make sure you're in control of time management for the ACT, which is key to getting the highest score possible on the test. I wouldn't worry about the watch beeping, since it's quick and quiet enough to not be an issue. Just start the stopwatch when the proctor says begin, and then keep track of time according to your game plan, which is our next strategy. Tip number 3. Have a game plan for managing time. The ACT is a timed test, and time is especially an issue for the reading and science tests, which are designed to be difficult to finish for almost every student. If you don't go into each test with a game plan for managing time, there's a really good chance that you'll run out of time for the test. For the English test, time won't really be an issue, but just know that you have about 9 minutes for each passage. For the math test, you have 60 minutes for 60 questions, but the questions get harder at the end, so you want to make sure that you work faster at the beginning so you have more time for the questions that are harder at the end. For the reading test, you have about 8 minutes 45 seconds for each passage, and you want to read each passage in about 3 minutes plus or minus 30 seconds. For the science test, give yourself about 5 minutes for each of the non-conflicting viewpoints passage, a little less for the data representation passages, and a little more for the conflicting viewpoints passage. When you go into each of the different sections of the ACT, you should know what question or passage you should be on at a certain time and stick to this game plan to avoid missing any of the easy questions you might not get to otherwise. Tip number 4. Use authentic ACT practice tests to prepare. Did you know that most of the ACT practice tests out there are actually not really authentic ACT practice tests, but rather imitation practice tests that companies other than the ACT have created themselves? Now, some of them might be pretty good, but none of them really compares to using actual retired ACT practice tests, which are the only practice tests that will truly give you an accurate prediction of what ACT score you might get on the actual test. Currently, there are 11 real authentic ACT practice tests out there. 4 of them are free and they can be found in the Preparing for the ACT booklets, which you can find links to below. 5 of them are in the Real ACT Prep Guide, also known as the Red Book, and 2 of them can be found from the ACT online website, which you can register for. The best way to prepare for what you will actually see on the ACT is to use these real ACT practice tests, and then go to the other practice tests only after you've used up all of these real ones. Tip number 5. Take advantage of the special ACT test dates. Did you know that out of the 6 days that the ACT is administered each year, 3 of them are special? Well, how are they special? Well, for the December, April, and June ACT test dates, you can order something called the Test Information Release Form, which will allow you to receive a copy of your answers and test booklet so you can know what you missed and how to improve for next time. This resource is great for finding out what you need to work on for the next time that you take the ACT. Also, since you can take the ACT as many times as you want without penalty, it's a great idea to start taking the ACT early and use these test information release forms to get better and better each time you take the ACT. The slight extra cost for this form is well worth the knowledge you'll gain from it that'll help you improve your score for next time. Tip number 6. Develop your reading speed and comprehension by reading a lot of college-level nonfiction articles, magazines, and books beforehand. The most important skill that the ACT focuses on is reading speed and ability. This is because being able to read well is probably the most important factor to succeeding in college due to the sheer amount of reading that is required in college. This is why the ACT reading and science tests don't require you to actually come in knowing anything, but rather, all of the answers are in the test itself. The only problem, and it's a big one for most students, is that you need to be able to read and comprehend fast enough to be able to finish on time and get a good score. So, before you take the ACT, try to read as much as possible, specifically college-level nonfiction texts, which are the kind of texts that will show up on the passages that you'll see on the ACT. Now we're going to cover a few specific strategies for each section of the ACT. Tip number 7. For the English test, always keep in mind, less is usually better. This principle probably shows up more regularly than any other principle for the ACT English test. And if you simply keep this in mind throughout the entire test, you'll get a good number of questions correct. Generally speaking, the shortest or the shorter answer choices are more likely to be correct than longer answer choices, because one major skill the ACT focuses on for the ACT English test is being able to write concisely. So, if you see choices that add unnecessary words to a sentence, even if these choices make sense, they are probably wrong. If a choice is short and it makes sense in the sentence, then there's a really good chance that it's simply the correct choice. Tip number 8. For the math test, be ready to use the answer choices and try random numbers. Unlike in math class, for the ACT math test, you don't need to show your work or prove that you actually know how to do the problems the right way. All you need to do is pick the right answer through whatever means necessary. And sometimes the best way to do this, and in fact the way that the ACT wants you to do this, is to cheat by either using the answer choices or by putting random easy numbers into the question. The ACT is testing your problem solving and critical thinking abilities also, not just your math abilities. For some questions, the right way to do the question will simply take too long, and so the question is designed to see if you can figure out the shortcut to the question. So, don't feel bad about doing problems for the math test the wrong way. The writers of the ACT are oftentimes seeing if you can figure out these tricks to some of the problems. Tip number 9. For the reading test, practice reading each passage in about 3 minutes plus or minus 30 seconds. You don't have the luxury of reading each passage slowly and carefully and then trying to find the answers to each question slowly and carefully. You need a game plan to finish the test within the time limit, and the best way to do this is to make sure you spend only a certain amount of time reading each passage and then using the key pieces of information you gained through this initial reading to answer the questions efficiently. So, know how fast you need to read each passage and know what you want to be looking for as you read through each passage. Don't try to remember every little detail, but rather only the most important details and where to look if you need to find out more specific information. And finally, tip number 10. For the science test, use your fingers to keep track of information. For a lot of the questions that involve graphs, charts, and experiments, you're going to need to constantly go back and forth between the question and the information from the passage. If you just use your eyes, you're probably going to waste a good amount of time trying to find the place you're looking for. Instead, keep your fingers by the relevant question and information from the passage so that when you need to look back and forth, your finger will already be at the place you need to look at. Your finger is a physical tool that will help your eyes be more efficient for the ACT science test, so you can make the most of every minute you have. It would also be a good idea to use your finger for every section of the ACT in some way, but your finger is especially helpful for the reading and science tests, which are extremely limited in time. Using your finger helps you work more quickly and efficiently for these tests. So, these are the top 10 tips for getting a higher score on the ACT. Hopefully you found them helpful. Make sure to like and subscribe to support and stay updated with our videos. Thanks for watching, and I will see you next time. Hello and welcome to Here Tutoring. In this video series, we're going to fly through pretty much every math concept you will need to know for the ACT and SAT. The purpose of these videos is to help you figure out quickly which math concepts you already understand and which ones you need to brush up on. It's not meant to provide a detailed treatment of any one concept. As we go through these first several concepts, if you understand a concept, great. If you don't, write it down as a concept you need to study more on for later. So, buckle your seatbelt and get ready because we're going to cover a lot of ground really quickly now. Okay, here we go. Concept number 1. Definitions of integer, rational number, irrational number, prime number, imaginary number, and undefined. First, integers are whole numbers, including negative numbers and 0. Examples of integers are -2, 0, 3, and 7. Second, a rational number is a number that can be expressed as a decimal or a fraction. Examples of rational numbers are -0.45 and 3/4. Third, an irrational number is a number that cannot be expressed as a fraction or a decimal. Examples of irrational numbers are √2, √3, and pi. Fourth, a prime number is a number whose only factors are 1 and itself. A note to keep in mind is that 1 is not a prime number. Examples of prime numbers are 2, 3, 5, 7, and 13. Fifth, an imaginary number is a number that is used with the square roots of negative numbers. A rule is that I squared equals -1. For example, the square root of -1 would equal I. Sixth, undefined refers to an expression that has a denominator of 0. For example, the function a plus b over x minus c is undefined when x equals c. Concept number 2, order of operations or PEMDAS. PEMDAS stands for parentheses, exponents, multiplication, division, addition, and subtraction. This is the order that you do math in an expression. One thing to keep in mind is that multiplication and division go together and just depend on which one is further left in the expression, and addition and subtraction also go together and just depend on which one is further left in the expression. Here's an example of how to apply PEMDAS. In the expression 5 minus 4 squared divided by parentheses 10 minus 2 parentheses plus 3 times 6, we would do the parentheses or the 10 minus 2 equals 8 first, which gives us 5 minus 4 squared divided by 8 plus 3 times 6. Next we do the exponent or 4 squared equals 16, which gives us 5 minus 16 divided by 8 plus 3 times 6. Next we do the division since it is further left than the multiplication. So we do 16 divided by 8 equals 2, which results in 5 minus 2 plus 3 times 6. Next we do the multiplication at the right, where 3 times 6 equals 18, to give us 5 minus 2 plus 18. Next we do subtraction, which is further left than the addition, so we do 5 minus 2 equals 3, which results in 3 plus 18. Finally we do addition, so we do 3 plus 18 equals 21. Concept number 3, adding and subtracting negative numbers. To add a positive and a negative, there are 3 steps. First, ignore the signs. Second, subtract the smaller number from the larger number. Third, add the sign from the larger number. If the larger number is positive, then the answer will be positive, and if the larger number is negative, then the answer will be negative. For example, if we have -38 plus 25, our first step is to ignore the signs, so we have just 38 and 25. Second, we subtract the smaller number from the larger number to get 38 minus 25 equals 13. Third, the larger number 38 is negative, so we add a negative sign to our answer. So our answer is -13. To subtract negative numbers, simply recognize that subtracting a negative number is the same as adding a positive number. For example, 13 minus -23 is equal to 13 plus 23, which equals 36. Concept number 4, multiplying and dividing with negative numbers. To multiply and divide with negative numbers, there are 2 steps. First, ignore the signs and do the problem without signs. Second, if there is an odd number of negative signs, the answer will be negative. And if there is an even number of negative signs, or 0 negative signs, then the answer will be positive. For example, let's take a look at -3 times -5 times -2. Step 1. When we ignore the signs and do the problem without signs, we get 3 times 5 times 2 equals 30. Step 2. Here we have 3 negative signs, which is odd, so our answer is going to be negative. So our final answer is -30. Concept number 5, divisibility. A number is divisible by 2 if the last digit is even. For example, 36 is divisible by 2 because the last digit is 6, which is even. Next, a number is divisible by 3 if the sum of the digits is divisible by 3. For example, 357 is divisible by 3 because the sum of the digits, or 3 plus 5 plus 7, equals 15, which is divisible by 3. Next, a number is divisible by 4 if the last two digits are divisible by 4. For example, 524 is divisible by 4 because the last two digits are 24, which is divisible by 4. Next, a number is divisible by 5 if the last digit is 5 or 0. For example, 55 is divisible by 5 because the last digit is 5. Next, a number is divisible by 9 if the sum of the digits is divisible by 9. For example, 396 is divisible by 9 because the sum of the digits is 3 plus 9 plus 6 equals 18, and 18 is divisible by 9. Finally, a number is divisible by 10 if the last digit is 0. For example, 730 is divisible by 10 because the last digit is 0. Concept number 7, remainder. The remainder is the whole number left over after division. For example, 14 divided by 4 is equal to 3 with a remainder of 2. Concept number 8, absolute value. Absolute value is the positive value of a number unless the number is 0. For example, the absolute value of negative 4 is 4. And the absolute value of 4 times negative 5 plus 13 is equal to the absolute value of negative 20 plus 13, which is equal to the absolute value of negative 7, which is equal to 7. Concept number 9, the number of integers from one number to another number. To find this value, we subtract the two numbers and then add 1 to include the first number. For example, the number of integers from 12 to 25 is equal to 25 minus 12 plus 1, which is equal to 13 plus 1, which is equal to 14. Concept number 10, finding a particular digit in a repeating decimal. To do this, there are 3 steps. Step 1, what number digit are you trying to find? Step 2, how many digits are repeating? And step 3, find the multiple of your answer to number 2 that is closest to the digit you're trying to find, and then count up or down to find the digit you're trying to find. For example, let's say we're looking for the 101st digit of 6 divided by 11. Step 1, we're looking for the 101st digit. Step 2, 6 divided by 11 is 0.5454 repeating, so 2 digits are repeating. Step 3, the digit of every multiple of 2 is 4, so the 100th digit is going to be 4, therefore the 101st digit will be 5. Concept number 11, adding or subtracting matrices. To add or subtract matrices, simply add or subtract the spaces that correspond to each other. For example, to add these two matrices, the top left will be 1 plus 1 equals 2, the top right would be 2 plus 5 equals 7, the bottom left would be 3 plus 2 equals 5, and the bottom right would be 4 plus 0 equals 4. Concept number 12, finding the mean or average. The average or mean is the sum of all the numbers divided by the number of numbers. For example, the average of the numbers 12, 15, 19, and 22 will be 12 plus 15 plus 19 plus 22, all divided by 4, which equals 17. Concept number 13, the trick to finding the average of evenly spaced numbers. To do this, just average the smallest and largest numbers. For example, what is the average of all the even numbers from 12 to 36? Since these numbers are evenly spaced, we can simply do 12 plus 36 divided by 2, which will equal 24. Concept number 14, the trick to finding a number that will bring an average up. There are 2 steps to doing this. Step 1, multiply the final average by the total number of terms, including the number you are adding. Step 2, subtract the numbers you were already given. For example, Jim's average score after 4 tests is 88. What score on the 5th test would bring Jim's average up to exactly 90? To do this, we first do 90 times 5. 5 is the total number of scores, including the added score. 90 times 5 equals 450. Second, we do 450 minus 88 times 4, since 88 was the average of the 4 original scores. We end up with 98, which is our answer. Concept number 14, factors and multiples. A factor is a number that divides into an integer with no remainder. For example, the factors of 20 are 1, 2, 4, 5, 10, and 20. A multiple is a number you get by multiplying a number by positive integers. For example, multiples of 6 are 6, 12, 18, 24, 30, and 36. Concept number 15, prime factorization. Prime factorization is when you keep breaking a number into factors until all the factors are prime. For example, the prime factorization of 48 might look like this. 48 equals 12 times 4, 12 equals 3 times 4, and the 4 on the right equals 2 times 2. Finally, the 4 on the left also equals 2 times 2, so we end up with 3 times 2 times 2 times 2 times 2 for our prime factorization of 48. Okay, we're going to stop here for now. Watch our next video to review the next several math concepts. We hope you found this video helpful. Thanks for watching, and I will see you there.
Hi, this is Mario with Mario's Math Tutoring, coming to you with a very special video series, and we're going to be talking about 21 different concepts to help you boost your score on the ACT math section. So we're going to be going through 21 concepts. Some of these you might know really well. You can go ahead and skip onto the ones that are more difficult to you. But we're going to go through them just one by one. These are ones that are commonly seen on the tests. It's something you want to familiarize yourself with. And you might want to try pausing the video, doing the problem first on your own, and then checking it to see how to solve it. We'll do it together in this video. It's up to you. However you feel it's going to help you best, go ahead and approach it that way. Let's get right started into this video lesson, okay, talking about proportions. So proportions is an important concept to understand on the ACT, and basically what it is, it's just a ratio that's equal to a ratio. So together that forms a proportion. So let's take a look at these two examples. Go ahead and see if you can solve them on your own, and then we'll go through them together. So the first one here, we're just saying, okay, what is the circumference of this circle? Okay, and they give us the arc length is 10 centimeters. So how would we do that? Well, we're going to make a proportion, and the way we're going to do this is we're going to say for every 90 degrees, okay, see 90 degrees, that's the part, okay, of the entire circle. And if we compare that to the entire circle, 360 degrees all the way around, okay, that ratio is going to be the same thing as this arc length, 10, is to the entire circumference. We'll just call that C. So again, all we're doing is we're just doing the part to the whole equals the part to the whole. These two ratios are equal to each other. Together they form a proportion, and you can cross multiply across the equal signs. That's what most students usually do. You can reduce this first if you want. I think I'll do that. So that's 1 over 4 equals 10 over C. And if I cross multiply, I get C equals 40, and that's just going to be centimeters. Okay, so that's number one. Number two, this is just another common proportion type problem, and that's where it's a sunny day and a shadow is being cast by a tree. You can easily measure the distance from the base of the tree to the tip of the shadow here. Let's just say that's 20 units, 20 feet. And say you're about 6 feet tall, and say that your shadow is about 4 feet in length. So these two triangles are similar to one another, which means that the corresponding sides are proportional. So we're going to make a proportion here, and I'm just going to do the same thing. I'm going to say shadow to shadow. Okay, so the person's shadow to the tree shadow is the same as the person's height, okay, that ratio, to the overall height of the tree, h. And then all we're going to do is we're just going to cross multiply. So we have 4h equals 120. Okay, so this diagonal multiplied together equals that diagonal. And then we're just going to divide by 4, and you can see that's going to be 30 feet. Okay, that's the height of the tree. Okay, continuing on to lesson number 2 in our ACT math series, we're going to talk about averages. So here's the formula we're going to be using over here to find the average. It's the total divided by the number, how many of the items that you have, that equals your average. So when you divide those two, you get the average. A common example would be like if you took 10 tests over the course of your class, and you add up all your points that you scored on the tests, you divide by the 10 tests, and that would give you your average test grade, per test, right? Now on the ACT, they don't always, give it to you in a straightforward fashion like that. They might ask you for what's the total of all your test scores, or they might ask you for like how many tests did you take if your average is this, and they give you this. So they may give you 2 of the 3 parts, and you have to find that missing component. It won't always just be straightforward with the total divided by the number, and you just have to divide. So I'll show you in this example what I mean, and you can try this on your own if you'd like. So this one, it says if the total of your calorie intake over the past 6 days is 11,400 calories, how many calories would you need to consume today to have eaten an average of 2,000 calories per day? Okay, so do you understand the question? Basically what we're trying to do is we're trying to get an average intake of 2,000 calories per day. So we know that's our average that we're looking for, 2,000. And we know that there's 7 days in a week, okay, so for the total for the 7 days, so we're dividing by 7. But it looks like so far we've consumed 11,400 plus whatever we're going to consume on that 7th day. We don't know what that is, so we're just going to make it a variable. We're just going to call it x. Okay, so now what we can do is we can solve this equation, and we can do that by cross multiplying, or you could just multiply both sides by 7, okay, like that. So this equals 14,000, and then you have 11,400 plus x equals 14,000. Subtract the 11,400 from both sides, and that's going to give you 2,600 calories that you need to consume on that 7th day to bring your average up to 2,000 calories per day. So definitely want to memorize the average equation, average formula, and just keep in mind that it won't always be in a straightforward fashion, but just go ahead and write down the formula, start substituting in what you know, and then you can solve for what you don't know. I'll see you in the next lesson. Okay, the third concept we're going to talk about that's tested on the ACT is probability. So you want to understand how to work with these basic probability questions, and the formula that you want to know is this one right here. Probability equals the number of successes divided by the total possible outcomes. So a quick example would be like if you had a spinner, okay, like this, and just say it was divided into 3 sections, 1, 2, and 3, okay? And you spin the spinner and you say, what's the probability that you land on the number 1? Well, there's 1 chance of success out of 3 possible outcomes, and you can see these are all evenly divided, so you have an equal chance of landing on each one of the 3. So your probability is 1/3, 1 chance out of 3. Okay, so that was kind of a very basic one. Let's take a look at a little bit more challenging one. And this one here says, in a 4-digit lottery, okay, 1 through 10, where digits can be repeated, what is the probability that you choose the correct number or pick the correct number? Well, one way to analyze this is that how many numbers are there? Well, okay, for the first number, there's basically 1 through 10. So you have 10 possibilities for the first digit. Since you can get that same digit again, there's 10 possibilities for the second, third, and fourth. And by multiplying those together, we know that there's 10,000 possible outcomes. Now there's only 1 correct one, so the probability of guessing the right one would be 1 chance, okay, of success out of 10,000 possible outcomes. So your probability of getting the right answer, okay, by just guessing 1 time would be 1 out of 10,000. So again, probability, number of successes divided by the total possible outcomes. If you just take a note of how many there are total and how many that you want, those are the successes, and divide, you can calculate the probability. Okay, concept number 4 is multiplication counting principle. So what we're going to talk about in this video is how to find the total possible outcomes using the multiplication counting principle. We'll take a look at an example, see if you can solve this one on your own, and then we'll go through it together. So for breakfast, you choose either eggs or cereal, and then you choose to drink coffee, tea, or milk, and then you choose a piece of fruit, either an apple, a pear, or a banana. How many different breakfasts are possible? So one way to solve this problem is to draw a tree diagram, and the way you can do that is just think of it as, you know, a fork in the road. You're making a decision. You're either going to go with the eggs or you're going to go with the cereal, right? And then if you decide to go with the eggs, you could pick coffee, tea, or milk. Okay, so we have 3 choices there, coffee, tea, milk. But if we went over here with the cereal, we still have a choice of coffee, tea, or milk. And then once we make these decisions, we have 3 more. We can either have an apple, pear, or banana, right? So apple, pear, banana, apple, pear, banana, apple, pear, banana, apple, pear, banana, apple, pear, banana. So I'll just write those in real quick. So A, P, B, A, P, B, A, P, B, and A, P, B. Now, if you think of this as kind of like a choose your own adventure, if you go down this branch, then you can pick 3 choices here and then 3 choices. So you could either end up going all the way down here, all the way down over here, but eventually you're going to end up at one of the ends of these branches, and you can see, you can count them up. There's 3, 6, 9, 12, 15, 18 possibilities. So there's 18 different breakfasts. But you can see that takes a long time to do that, and on the ACT you're obviously pressed for time. So the easier way to do this is just to say, okay, I've got 2 choices for the main part of my meal, the eggs or the cereal. So that's 2 choices. And then I've got 3 choices for something to drink. So that's times 3. And then we've got 3 choices for a piece of fruit. And if you multiply all these together, you can see 2 times 3 is 6, times 3 is 18, and we get the exact same outcome This is just more of a visual representation, but in the interest of time, you just multiply how many choices there are in each category, and that'll give you your total possible different breakfasts in this case, or the different number of outcomes that you can have. Okay, moving right along, the next concept that's important to understand for the ACT are functions. Okay, so functions in the normal way that you learn them in your math class look something like this: f of x equals, in this case 2x minus 7, and the way you solve this is whatever's in the parentheses, see the 3 here, that's your x value, that's your input. So you're putting that x in place of x on the right side of the equation, and you're simplifying. So here you would have 2 times 3 minus 7, which is -1. So f of 3 equals -1. So you have an input, and then you substitute on the right side and simplify. But on the ACT, they want to test you that you understand the concept of how functions work with an input and an output, but they put it in a slightly different form that sometimes students aren't used to seeing it in. And I'll just show you an example here. See if you can solve this one. If L square m equals m squared minus L squared, what does 2, this is supposed to be a square, what does 2 square 7 equal? Well, don't freak out when you see this symbol. You might think to yourself, we've never learned this square, what does this represent, right? Just see if you can follow the pattern. You can see whatever here is in front of, or to the left of the square, that's going to go in here for L on the right side, and you're going to square it. Whatever's here to the right of the square, m, okay, is going to go in here for m, and you're going to square it, and then you're going to subtract. So it's just following the pattern, realizing that there's an input, and then there's going to be an output. You're going to do a substitution and solve. So in this particular problem, if we just go ahead and solve it, it looks like 2 is our L value, so that's going to be 2 squared. 7 is our m value, so that goes here, so that's 7 squared. And so we have 49 minus 4, which is 45, and we got it. So this is an easy one to get right on the ACT. You just have to recognize the pattern. And if you're interested in learning more about all these concepts that we're talking about, these 21 concepts, I do have a course. You can check it out. I'll have a link, but we're going to continue on going through the 21 concepts. So let's go to the next one. Okay, cruising right along, we're going to get into the next concept, which is circles. And there's usually one of these problems on the ACT. It's an easy one to get right if you know the equation of a circle. So this is what you want to memorize right here. X minus h, the quantity squared, plus y minus k, the quantity squared, equals r squared. Now hk is the coordinate of the center of the circle, and r is the radius of the circle. So we're going to do an example, and I'll show you what I mean. You can see if you can do this one on your own first if you'd like, and then we'll go through it. So x minus 7 squared plus y plus 3 squared equals 64. What is the center and the radius of this circle? Okay, do you have it? All right, so the center is at positive 7, negative 3. Now notice how it's the opposite, okay? It's positive 7, negative 3. It's the opposite of this sign. It looks like minus 7, but see how this is x minus h, so the h is just 7. And over here with y plus 3, this is really like y minus a negative 3. So if you can remember, it's just the opposite, sign. So that's the center of the circle. And then the radius, you have to realize that this is actually the radius squared here, 64. So by taking the square root, the radius equals 8. Now just to show you, if you wanted to graph this, you're going to go right 7 and down 3. Okay, that's the center of the circle right there. And then you're going to go, to the left 8 units. You're going to go to the right 8 units. You're going to go up 8 units. You're going to go down 8 units. And then you can draw the circle through those 4 key points. So definitely want to know the equation of a circle. It's an easy one to get right on the ACT. Let's move right on to the next topic. Okay, if you watched this far, I'm sure you're picking up some excellent concepts that'll help you boost your score on the ACT. Just a quick tip, if you're studying and you're practicing to take the ACT, you obviously want to take some of the previously released tests. I would go through those tests, time yourself, 60 minutes, 60 questions for the math portion, and then, go through them and look at the ones that you've gotten wrong. Try to figure out what you're not understanding, and then go ahead and after you iron out some of those difficulties, go ahead and take another practice test. But what we're going through here, these 21 concepts, these are ones that students oftentimes make mistakes on, and just a little twist, a little bit of understanding, how the problems change slightly can make a big difference in solving those problems more quickly and of course more accurately. So in this next video, we're going to be talking about percentages, and this is something that you're probably familiar with a little bit already. You know how to convert from a percent to a decimal just by moving that decimal point 2 places to the left, right? But on the ACT, what sometimes is helpful is to think about how much more than 100% or how much less than 100% you're working with. So for example, if you go to a store and everything's 30% off, instead of focusing on the 30%, focus on the 70% that you're actually going to pay for the item. So you could take an item that's $40, multiply it by the 70%, and then you know exactly what it is that you're going to pay. Instead of figuring out what you're saving and then subtracting it from the original amount, this is just allows you to do it in one step by focusing on 100% minus the 30%. Let's take a look at an example. See if you can do this one on your own, and we'll go through it. Always eager to improve, you decide instead of swimming your usual 30 laps, that you'll increase it by 10% today, and then by 20% more than that amount, okay, that you swam today, tomorrow. How far will you swim tomorrow? So do you understand the question? It's basically saying that you normally swim 30 laps, you're going to swim 10% more today. Tomorrow, you're going to increase on your previous amount, okay, so an additional 20%. So the big mistake that students often make is they'll just say, well, this is 30%. I'll just add these together. But that's not quite right. What you want to do in this problem is you want to look at it from this perspective. You're increasing your distance by 10%. That means you're swimming 110% of, okay, of means times, right, of your previous amount, the 30 laps, okay? Then you're taking this entire quantity, okay, and you're increasing by an additional 20%. So that means you're swimming 120%, okay, more than this, okay, this whole quantity here. We're going to convert the percent to a decimal. So this is 30 times 1.10. I'm just moving that decimal point 2 to the left. And then we're multiplying this whole quantity times 120%, which is 1.20. Now let's go to the calculator. If we do that, I just want to show you something really quick. 1.1 times 1.2 is actually 1.32. So what that means is you're actually increasing the amount that you're swimming by 32%. See, not 30%, it's actually 32%. And if we multiply by 132%, we're going to do it all in one step. So we're going to take 30 times 132%, which is 39.6, okay? So we're just going to say 39.6 laps. Okay, so that's how you work with these percentage problems. Think about 100% plus or 100% minus, and then take it from there. Okay, concept number 8 that you want to take another look at when you're preparing for the ACT math section is factoring. So hopefully you remember all the different types of factoring that there are. I'll just show you a couple in this short segment, but you might want to go back and review some more factoring. So one type here is the difference of two squares. So a squared minus b squared, so a perfect square minus a perfect square, you factor like this: a plus b times a minus b. It's a sum and difference pattern. Another type where the leading coefficient is 1, when you have a trinomial like this, you ask yourself what two numbers, okay, multiply to c, but those same two numbers have to add to this middle coefficient b. So those are just a couple of different types. We'll do a couple examples and then we'll take it from there. So 9x squared minus 100. One thing that jumps out at me right away when I see this is that there's only two terms. So that means it's a binomial. And I notice that there's a minus sign in between, so it's a difference. And then the other thing that jumps out at me is that these are two perfect squares. 9x squared is really 3x times itself, right? And 100 is really a perfect square because 10 times 10. And all we have to do is make one of these plus, one of these minus, and we factored it. That's a difference of two squares pattern. This one here is a trinomial. I notice the leading coefficient is 1, so I just have to ask myself what two numbers multiply to negative 12 Okay, I'll just diagram that out. But at the same time, they have to add to this middle coefficient, which is -1. It was negative x, but you can just think of that as a 1, -1. So that looks like it's going to be -4 and +3. So when we factor this, this is going to be x minus 4, x plus 3. And you can check your work by distributing the x twice and distributing the -4 twice, and then simplifying, and you'll get back the original. So this has just been a little reminder to you about factoring. Go ahead and review that a little bit more, and let's continue on to the next lesson. Okay, now we're going to look at number 9, the rules of exponents. So on the ACT, they want to make sure that you understand the basic rules of exponents, but like all the problems on the ACT, there's usually a slight twist that makes it just a little bit more challenging than what you learned in your math class. First, let's go over the rules of exponents, then we'll do an example problem. So first things first, when you multiply and you have the same base, what do you do to the exponents? You add them. When you divide and you have the same base, what do you do to the exponents? You subtract them. You take the numerator's power minus the denominator's power, and you keep the base as it is. When you have something raised to a negative exponent, that negative exponent doesn't make the number negative. It just tells you to take the reciprocal. So you can write this as 1 over x to the positive n power. Anything to the 0 power is 1. And then this last one, when you have a fraction raised to a power, you can distribute that power to the numerator and the denominator. So this is x to the n divided by y to the n. So let's look at a possible problem that could be covered on the ACT. And you can see it's in a slightly different format here. It's a little bit more complicated. And we want to find m. So see if you can do this one, and we'll go through it. So the first thing that I notice is we're multiplying all these together. And when we multiply, what do we do to the exponents? We add them. So this is going to be x to the 2 plus 3, which is 5, plus m. So x to the 5 plus m over x to the 7th equals x squared. Now what do we do when we divide and we have the same base? We subtract the exponents. So we have x to the 5 plus m minus 7 equals x squared. Now you can see that we have the same base. Okay, so we can set these exponents equal to each other. 5 minus 7 is -2 plus m. That must equal 2. So by adding 2 to both sides of this equation, you can see that m equals 4, and that's our solution for m. So what made this a little bit more challenging is that we had to do multiple steps, and we also had to set the powers equal to each other because we had the same base. So this is one possible problem that they could give you on the ACT, but again, you want to make sure you just review and understand these rules of exponents. Okay, our number 10 concept is Pythagorean triples. So you probably already know the Pythagorean theorem. A, B, and C. Okay, when you have a right triangle, A and B are the two sides that make up that right angle. C is the hypotenuse, that's the longest side. And we know that A squared plus B squared equals C squared, or the sum of the legs squared equals the hypotenuse squared. But what you may not know or may not remember are these Pythagorean triples. And here's 4 of the ones that come up the most on the ACT. They're the most common because they're the smallest triples, but they're integers that form a right triangle. Okay, so 3, 4, and 5, if you take 3 squared plus 4 squared, that equals 5 squared. 5, 12, 13, 8, 15, 17, 7, 24, 25. So the number here on the end on the right, that's the hypotenuse, that's the longest side. But what you want to realize is that if you take any one of these Pythagorean triples and you multiply all the sides by the same number, that will also form a right triangle. So for example, if I multiply all these by 2, 6, 8, and 10, these also form a right triangle. So by recognizing these, you can save yourself time when you're doing these problems on the ACT. I'll show you what I mean in this example. See if you can solve this on your own. We've got a right triangle here, and they give us the two sides or the two legs, 15 and 36, but they ask us to find the hypotenuse x. Now you could go ahead and substitute into the Pythagorean theorem and solve for c, and that's perfectly fine.